Welcome to The Explainer. Today, we're going to reframe something you probably remember from high school. We so often think of physics as just this boring set of formulas and endless calculations scrawled out on a massive chalkboard. But it's really not. Physics is actually this epic human adventure. It's the captivating story of our historical journey to understand the greatest secrets of the night sky and really the fundamental reality we live in.
I want you to imagine for a second that you're an ancient human. You step out into the dark night, you look up at thousands of stars and a glowing moon in just absolute awe, and you ask yourself, how does the universe actually work?
Why do things inevitably fall back down to the earth when you throw them, instead of just floating away into the empty void?
Or how does light travel all the way from the distant sun directly into our eyes? And for that matter, why can we see stars that are unfathomably far away?
Okay, let's dive into this, because attempting to answer these massive fundamental questions about what everything is truly made of, well, that is the very definition of physics. It's not just math. It's humanity's ultimate quest for answers.
Chapter 1. The Spark of Curiosity. From Guessing to Experimenting.
So, back in the ancient world, people observed the sun, the moon, and fire, but they really only had guesses about how it all functioned. It actually wasn't until humanity realized that rigorous experimentation is the absolute foundation of science that things changed. And our chronological journey brilliantly illustrates that. We start out as ancient observers, then jump to Isaac Newton's groundbreaking laws about 400 years ago, hit Albert Einstein's total rewrite of reality in 1905, and arrive right up to the modern day, where we're using massive particle accelerators like CERN. It's a continuous, escalating quest.
Chapter 2. Laws of the Universe. Newton and the Forces That Bind Us.
Let's transition back to about 400 years ago. This was when Isaac Newton arrived and shifted physics into a completely new, mathematically grounded direction. We all intuitively know the old saying, what goes up must come down, right? But Newton asked why. He defined gravity as this invisible force where the Earth actively pulls objects towards it. And by creating these strict, rigid rules of movement, he gave us the scientific foundation to predict exactly how a car accelerates or, amazingly, how a rocket launches into space.
But the journey definitely didn't stop with gravity. Later on, scientists realized that electricity and magnetism were somehow connected. Then James Clerk Maxwell put them together into this massive mathematical framework, revealing a shocking twist. It turns out the very light we use to see the world is actually an electromagnetic wave. This discovery was absolutely massive, beautifully paving the way for modern radio, radar, and literally all wireless communication.
Chapter 3. Bending Time and Space. Entering the 20th Century.
Now, this is the era where things get genuinely weird. Scientists started questioning if the rigid laws of the past were really the whole story. Enter 1905, when Albert Einstein absolutely blew the world's mind. With his theory of relativity, he proved that time and space are deeply physically connected. He showed us that time isn't just some ticking background clock. Actually, the passage of time can dynamically change depending on how fast you're moving. Crazy, right?
And out of this came perhaps the most famous formula in human history, E equals mc squared. This elegantly proved that mass and energy are fundamentally linked. They're essentially just two forms of the exact same thing. This incredible paradigm shift, along with general relativity, finally gave us a framework to understand gravity on a truly cosmic scale, helping us comprehend some incredibly bizarre objects, like black holes.
Chapter 4. The Micro and Macro Frontiers. Quantum worlds and expanding universes. So the crucial point is, scientists decided to see what happens when you zoom in and make matter smaller and smaller. They realized that everything is made of atoms, which break down into electrons, protons, and neutrons. And beneath that, well, we enter the incredibly strange realm of quantum physics. In this bizarre microworld, everyday logic simply stops working. Particles start behaving in seemingly impossible ways, like light acting as both a wave and a particle at the exact same time. It's a real mind-bender.
And this perfectly juxtaposes the sheer scale of physics today. On one end, we've got macrophysics, studying massive galaxies, black holes, and the expanding cosmos. And then on the flip side, we have microphysics, diving deep into protons, neutrons, and invisible fundamental particles. We are literally studying the absolute largest and the absolute smallest things in existence, simultaneously.
Just think about this number for a second. 13.8 billion. By looking out into the cosmos, physics has allowed us to calculate that our universe is 13.8 billion years old. To put that into perspective, it's just an unfathomable amount of time. And remarkably, the most surprising discovery of all is that it hasn't stopped growing. The universe is actually still expanding right now as we speak.
Chapter 5. An Unfinished Story, Modern Miracles and the Mysteries That Remain.
Now, what's really interesting about this is how it actually impacts your daily life. Let's bring these abstract concepts back down to reality for a second. Practically everything you rely on is a direct product of this science. Mobile phones, GPS navigation, satellites, lasers, the computers and internet delivering this very explainer to you, even life-saving medical imaging. The devices and networks we use every single day rely entirely on these fundamental physics discoveries.
But the work isn't done. Today, scientists at massive research centers like CERN are using these colossal particle accelerators. They are literally smashing matter together at unimaginable speeds, actively trying to uncover the most foundational, basic building blocks of our reality. They want to know what everything is essentially made of at the absolute lowest level.
Because despite all our amazing technological progress, there are still some massive remaining mysteries out there. I mean, what is dark matter? What is dark energy? What is the actual true structure of the universe? And how in the world do we unify the physics of gravity with the completely weird rules of quantum physics? These are the biggest unsolved puzzles of our time, and honestly, someone watching this explainer right now might just be the very person to discover these answers in the future.
Which brings us to our final, lingering question. What is the universe's ultimate reality? We've come so far from those ancient humans just staring up at the stars, but the epic story of physics is an adventure that is far from over. The biggest secret of the universe is likely still out there, just waiting to be discovered.